Okay, so I'll be showing you how to create beautiful images of your structures after extracting values like the bond length and bond angle for geometry optimization. So you can see here that we have a lot of files, and most of those files appear in double because the first one is the input and the second one is the output file of a particular compound. So I've already showed you in the previous video how to extract your bond length and bond angles. So the next thing is, how do you visualize? So we are going to open this in gas view. Open it in gas view. It's loading. So this is our structure. This is how it looks like in gas view. So when it comes to visualization, the image of the structure you are working with has to look very appealing to whoever is going to be looking at it. It has to be beautiful. So to do this, we are going to be using a different set of files, which we call the checkpoint files and the formatted checkpoint files. So you can see that what works with your gas view mostly is your input file, your log file, but we have other softwares that makes use of files like checkpoints and formatted checkpoint files. So what you need to do now is, on your navigation page, you go to calculate, Gaussian calculation setup, and you select, you find the basis set that was used in optimization. So the basis set used in optimization was 6311G plus D, and then this space is empty. So once you've gotten this, you close it, and then you go to tools. Under tools, you come to the molecular orbitals section, which has this symbol. You click on it. So under here now, we go to new MOs. Before that, under the calculation setup, if your wave function happens to be unrestricted, you make sure it's restricted all the time. So you restrict it and you come to new Gaussian MOs and change the basis set that you have taken note of earlier. So the basis set was 631G with a plus and a D, and this space was empty. So after that, you're going to see a directory for your checkpoint file to be generated. So it's going to be generated in the same folder where your log file is. So you generate. So you can see that it's generating at this point, so you have to wait. It's going to take some time depending on the complexity of your structure. Really good work. I should have used the smaller structure, but our calculation is complete. So Gaussian job has completed. Do you want to close the Gaussian window? Yes. And you close this too. Then come back to your folder where you opened your file from, and you're going to see that a checkpoint file has been generated of that compound. Now that we have our checkpoint file, the next step is to generate our formatted checkpoint file. So minimize this and close this, close your gas view. Okay, then the next thing you do is open your Gaussian, and on Gaussian now you're going to see utilities, form check. Under form check, you have to locate the folder where your desired checkpoint file is. So the checkpoint file we just generated is here, I guess. Okay, should be here. Okay, so this is our checkpoint file. Double click on it and you're going to have this. So once you see this directory, it means your formatted checkpoint file with the fch stuff is ready. On some systems, this directory is not going to appear, it's just going to show C scratch, but on my system it's showing my local disk directory. So once you see this, your formatted checkpoint file is ready, you can close this. So now, how do we visualize for geometry optimization? We do that using Chemcraft. So this is Chemcraft here. I'm going to open Chemcraft. So this is how your Chemcraft interface looks like. So we are going to be visualizing for that compound. So the first thing you want to do is go to files, go to open, and locate the file that you are working with. So I think the formatted checkpoint file we just generated is here. Okay. No. Look at it here. This is the checkpoint. This is, look at it here. You can see it's formatted, Gaussian formatted checkpoint file for that particular compound. So you tick on it and it's going to open. So now on Chemcraft, you can do a lot of editing as you want. Yes, a lot. So this is our compound, but now appearing in a different color and on a different background, not the normal blue background you see on gas view. So to change the colors of how your compound look, you can't go to display. Under display, you go to, we work with pattern style here, but there are other styles. You have the gas view style. You can see publication 1, 2, depending on what you want, depending on how you want your structure to look. Yes, but I am going with pattern style. This is the mostly used. So I am going to customize after selecting my style, and once I click on random colors, I keep getting different colors. And mind you, if you happen to close your chem drawer after selecting a particular color, maybe you want to do this visualization for a set of compounds, after selecting a particular color, if you close your Chemcraft, this color, you will never find this color again. So you have to be certain about what you want, how many set of compounds are you going to use a particular color for, and make sure you don't close your Chemcraft till you're done with all the compounds you want to visualize. So let me choose a color. I'll go with something bright. Yeah, let's go with this. So after selecting a color, what else can ChemDraw do? So these are for directions, help you keep your compound in whatever way you want to keep. This for zooming in, zooming out, the same things, up, down, left, right. So you can also visualize your bond lengths in that compound. So if I happen to choose a bond between this atom and this atom, I would see my bond showing below 2.65, and I can choose to show. Yes, the same thing with a bond angle. If I'm selecting a bond angle, I could select the 3 atoms involved and choose to show, and it's going to show. Make sure your image is always bold, like it doesn't have to look small. Yes, and you can make sure you put your labels, yes, so that people can know what atoms are in this compound. So some people can just go with the numbers depending on what you're visualizing, the atoms or both. I prefer both. So this is it for visualization using ChemDraw for geometry optimization. So after you get this image, now this is the structural representation of your compound. How do you save it? You come to this icon here that looks like a camera, and you click on it and you choose your desired width and height. I like to leave mine at this and press OK. So you can now come to your document, your Word document, and under your analysis where you're discussing, you can choose to present it just as this one is presented. You can choose to just paste, yeah. You can choose to present it in your document. So you see I have it here looking very beautiful. So that is it.